Hello. Hi, everybody. My name is Justin Castilla. Thanks for joining me today. Hopefully, this will be an interesting talk. Databases sometimes are not the most exciting things in the world of technology and development, but I'd like to think that I can make it slightly more bearable. So, if you have any questions or anything like that, just go ahead and throw them into the comments. I will be able to see them. Hey, Skiddy. Hey, Shimmery. Hello. Nice to see you all. Um, so hopefully this will be easy to understand. And if you want to learn further, there are plenty of avenues to explore with Redis, with me, or with any of our other advocates or instructors. So lots of options. So let's start. So, question: what is Redis? Well, first I want to tell you what we're going to cover. You might have heard this app called Pokemon Go. Um, we're all up in it. We're a software that a lot of online applications use. We're a primary data store or database, but we're off more often than not. We work in tandem with an existing data storage. So if you have a SQL database, we're right next to it. We're basically making things a lot faster. So we're going to go over Pokemon Go, and we're going to do a little bit of a analysis of what their challenges were, what their solution was, and some of the ways they actually implemented those solutions. And then I'm going to go over a couple of use cases that most people use Redis for. So we're going to go over queues, the queuing data structure, a player leaderboard, so like the top 5, top 3, top 10 players. And then we're going to learn how to cache data with strings and key expiry, which expiration is a huge concept to really kind of get comfortable with when it comes to caching. Caching is what makes crappy implemented databases super fast. So it gives you some leeway to make your existing database structure or your third-party API requests just faster. And it ultimately saves you time and money in the end. And then if we have time, we'll go over a little bit about indexing JSON. You can store JSON in Redis as well, and then you can index it for querying and search. So you can do like full text search, searching like with tags, numbers, and stuff like that. And I'll go over that. Also wanted to highlight that this repository, this slide deck is in the repository you see down there, GitHub Redis Labs -training /MLH Redis -intro. So go ahead and go to that org. You'll see a ton of information on how to implement Redis within your application. We have a ton of sample apps using Node.js, Python, and Java, C#, Go. I think I saw an Erlang in there. Wasn't me. I didn't do that, but somebody did it. So without further ado, let's start. All right, so Pokemon Go had a problem. They're playing raid battles, and that means a huge concentration of users all in one location. And you have to have all of those users in one server for that data to interact quickly. Now, scaling that out is a challenge because of traditional servers. They are not always in memory being literally in RAM. Redis, all of our data is stored in RAM. So that's why it's generally much faster than, say, like volatile, like non-volatile memory, like SSDs or like the spinny disks. We have everything in RAM, and then we offload to a hard drive, like after maybe 30 writes or 30 reads from the database. So the solution is they implemented Redis. So when they have battles, they'll create a Redis server, and that Redis server will hold all of the data that's relevant to that battle. And I have a link at the bottom too if you actually want to read the article, the analysis. They use much prettier words than I can, and they actually show some data graphs as far as the speed ups that Redis actually afforded Pokemon Go. So Redis servers are created at the raid battle, and we actually physically have them as close to possible to the actual battle. So if there's a battle going on, like right now I'm in Philadelphia for a conference. If there's a battle going on in Philadelphia, they'll start up a battle server within some server location nearest to Philadelphia. I believe they use Google Cloud for their services. So they store data as JSON, and all actions that are going to occur, such as battling the different Pokemon, those are stored as a queue. And a queue is just a fancy word for a list, of course. And that way we can kind of offload the immediacy for one server to handle, like the results or of an attack. So you can have those in a queue. As the queue goes along, we can actually reduce the queue, thus having everybody attack a Pokemon or what have you. What else we have here? Also, we actually cache the data. So instead of actually going to their hard source of data, they use Redis. And that way, instead of having to go to their server farm that has the hard data, they just use Redis really quick. When that battle's over, you don't need this server anymore. So you just get rid of that Redis server. Poof, it's gone. And that's fine. That's totally fine. All the relevant data that is necessary, the battle results, who gets what XP, whatever have you, that actually goes to the normal database that Niantic uses. And the Redis server just goes away. And we're okay with that. So Redis is not a SQL database. It's NoSQL, but basically we store all of our data as different data structures. Hopefully you've heard of most of these. Some of these are a little old, but they're still really good, like bitmaps and bitfields. You can store a ton of information in those, but they're kind of rare because we can afford so much data now. Strings, lists, hashes. Hashes are basically objects within Redis. It's an object within Redis, so we can store numbers, strings, and booleans, and that's it. So no lists or anything like that. Hashes are kind of like JSON, but JSON, you have the ability to store more JSON within JSON, lists, things like that. Streams are very powerful, and they allow you to record objects, record hashes with a timestamp. So it's a list of timestamped objects. So that's really cool when you want to gather a lot of data, like a ton of data, and then go through it, have other services go through it at a later time. A later time being every night, every week, or like 20 milliseconds after it was written. Streams are very common in modern application design for when you want something done very quickly. We have sets. Sets are just lists that have unique members, so there's no repetition of the exact same data. Hyperlog is a probabilistic data structure, and that actually gives you a probability of that something exists or doesn't exist. And that's good for when you want something very fast. If you want to like check if a username exists, you use a hyperlog log. We have sorted set, which is just like a set, just a list of unique values, only they're all sorted by a score. So that is really nice because you could just throw something into a sorted set with a score and you can retrieve that data at any given time and it's already sorted for you. And that's very powerful because you don't have to run a sorting algorithm all the time. Sorted set just does it for you. And then lastly, geospatial. Geospatial is great because it actually contains a latitude and a longitude. And that's all it is. So you can actually create an object like a battle, like a Pokemon location, anything like that. And you can throw it into Redis and you can say, hey, Redis, what's, the 10, show me 10 battle locations within a 20-mile radius. And it will show you the first 10 that pops up based off the mathematics of your current location, latitude and longitude, and whatever is stored in the geospatial coordinates. So that's really cool. Now, these are all stored in Redis using a key. Now, a key is basically a way to address that value. So it could be anything all the way down to like the literal word foo, or it could be bar, or anything like that. It could be whatever you want. And you can kind of create your own naming convention as you see fit. Now, that could be cool in that it gives you a lot of freedom, but also it could give you an existential crisis because then you have to think about how you want to name things. We usually use a colon in our naming convention. If you ever watch any of our videos or go over any of our courses, So if I'm in a hotel, so I'm at in Philadelphia at the Sheraton, floor 10. I don't think anybody has enough time to actually find me. But so if I was to use a key for my location, I would list it as Philadelphia colon Sheraton colon floor colon 10. And that would actually give me something like maybe a layout of the 10th floor of the Sheraton in Philly. So you want to name your keys in a way that actually makes sense. And I'll have some examples of how I would name a key as we go through. Now that was Redis. Redis is open source. So you can download it and you can run it. You can actually look at the code that it's written in. It's all written in C. It's actually very easy to read. And you can use it to your heart's content. Redis Stack is owned and maintained by Redis Incorporated. Now they pay my bills, and they also offer cloud services, things like that. Now Redis Stack is still free, but you can actually look at the compiled code. It is available to you, but you have to request it. And what Redis Stack does is it actually builds on top of open source Redis, and it gives you some more capabilities, mainly JSON and search. So you can take any JSON data that you create and you can just throw it into Redis. There's no serialization. Oh, I'm getting ahead, but I'm really excited about JSON. I think it makes the world so much easier when working with Redis. So we have JSON, we have time series, which is a time-stamped list of values. So if you're like taking air quality measurements or temperature measurements or foot traffic, if you want to measure those things, you can use a time series, and that makes for some really powerful graphing. So you can look at charts instantaneously. That's a really cool data structure that a lot of people use. Also for monitoring the usage of your application. So how many people are hitting your servers per second, per minute, things like that. We have search, which allows us to index JSON and our hashes to be able to search via text or numbers, and I'll cover that later on. We also have a Bloom filter. Now, Bloom filter is another probabilistic data structure, and it gives you like a probably yes or a probably no within like 99%. So if you're okay with that risk factor of 99%, go with a probabilistic data structure. Those are super fast. They mostly do not store unique data like a username or a user's hash. They kind of just blend it. They kind of hash it into this magic number and they throw it into this data structure. So when you actually go into Redis and say, hey, was this username taken? Or like, has this user visited this page before? It'll tell you with most certainty that it's either yes or no. So those are the features, the main features of Redis Stack that I think that you should consider if you wanted to use Redis for your applications. Now, here's an example. I like to start off with the command line when I'm interacting with Redis, and it's simple as set and get. You use set and get throughout a lot of your development. So here I am setting the key cat to the value mocha, and then you see I'm setting dog to the value latte. And if I call get cat, I would get mocha. So it's very, very elementary in the beginning, and we want it to be. It's very fast. We don't want it to be difficult. There's no DDL structured language that you have to memorize to create all these large queries. We just keep as many commands as simple and consistent across the board. So you can use the command line interface. Also, we have this thing called Redis Insight, which is a GUI, just a graphical representation of the database that you can actually go in and play with. You can inspect your keys. You can see like how they actually look and perform. You can pull them out. You can learn some commands that you'll want to use on your clients. Now, speaking of clients, we have Redis Pi and Node Redis. So this allows you to use Redis within the language of your choice. Redis Pi and Node Redis are our most popular, and I would imagine you'd probably want to use those. We also have support for Spring and C# with .NET. And there's also quite a few other client libraries, but those are our 4 top ones. Okay, so let's start with some of these data structures. And again, if you have any questions, just like throw it out. I'm more than happy to explain. So a queue, like you get in the queue when you're like getting coffee or if you're waiting for a bus, things like that. There's a head of the line or head of the queue and the tail of the queue. And this allows you to preserve the structure of order of when something was requested. So in application design, a lot of times when you need to have a certain service done to a payload, you put them in a queue, a head and a tail, like this you see here. Now, this is just a list. It's a list that we treat with a certain rule. We push on the left, and then we pop to the right. Those are consistent list commands. Here I am showing an example of like a hotel housekeeping service. So if there are things that need to happen in the hotel, like, somebody needs to call a taxi for this customer, or room 101 needs cleaning, or I see here, room 484 is requested extra towels. You need to add that to a list for the consumers or housekeepers to actually pop off the list and do one at a time. So we have a producer on the left and a consumer on the right. And those are two terms that we use a lot in Redis with queues and also streams. So to create this queue, we're using the command lpush. Lpush means left push, or push onto the list onto the left. So you see lpush and then the word jobs. Jobs is going to be the key. So the key of the queue is jobs. And here we are. You can see that I actually have a string that looks kind of like JSON. And that's perfectly fine. That's perfectly fine. This is a small string, so it's not going to take a lot to deserialize and turn into JSON. And this is basically a structure for a queue. And this is very, very common in most application design. Now, if you want to actually remove something from the queue, on the right, you see rpop. So that's going to pop the tail end from the right. And so you see rpop jobs, jobs being, again, the key. And it's going to return that string value, which is room 101 job cleaning. And that's really all there is for a queue. Other commands that you might want to see is just like if there's a large queue, you might want to double it or cut it in half. So you have two different queues so you can work on it in parallel processing. So that would be the range command. But for the most part, you just have lpush rpop. This is also similar somewhat to a stack where you have lpush lpop, where you just put things on a big pile. And as you build up the pile, you pop one off from the top. And that, again, is just another common data structure. So I see a question. How is it different from MongoDB? That's a very good question. MongoDB and Redis are buds, 100%. Like, we are friends. I absolutely love their developer advocates, and we actually are on conferences quite often. And we're actually working on a bit of a collab, just the advocates, for some fun coding. So MongoDB is a JSON document store, and they also have built-in references and relationships within their JSON documents. We do JSON, but not as extensively as they do. We also do data structures with common data structure commands that you would use. So we somewhat share the stage, but more often than not, you have MongoDB and Redis kind of in your same application, just doing different things. So MongoDB might be good for your primary data store for JSON, whereas Redis would be really good for storing your cache or a queue, or storing a cache for your MongoDB, things like that. So hopefully that answers that question. That was a really good question. And I asked the same thing in my interview with Redis 3 years ago. And I answered that question probably every single time I go to a conference. So yeah, that's a good one. So let's look at now a leaderboard. Now, a leaderboard is really interesting because it sounds like an interesting challenge to create, but it's super simple with Redis because we have a sorted set. And again, a sorted set is a collection of unique values. So when you see a leaderboard, you're not going to see the same player multiple times. You're either going to be in first place, second place, third place. You can't be second and third place of the same category. It's not a list because in a list, duplicates can exist, but it's just a unique set. If you try to add an element that already exists to that set, it'll just be completely ignored. And that's how they maintain uniqueness. Now, each element in a sorted set has a score that's associated with it. And that could just be any kind of numerical value. It could be positive, negative. You can use floats even if you really wanted to get precise. It's whatever works for you. Um, but when you enter that score along with that element or member into this sorted set, Redis, upon insertion, is just going to keep it sorted for you. It starts from lowest to highest, but as developers, we all should know that if you want to go to like all the way to the end, you reference -1 to get the absolute last value, similar to like an array. And if you want the absolute first value, you index with 0. So it's quite easy to actually say, I just want the last 10, which would be -1 to -9. That would give you the 10th, I think. Yeah, -9 or -10. Sorry. I'm on East Coast time, and I'm usually used to West Coast. That's how you would get the top 10. Or if you wanted like the lowest 10, you'd go 0 to 9. Okay, I see one more question. So by default, it's lowest to highest, but we can alter that as per needed. Yeah, there's a command called, oh, I have it on the screen here. Z-range returns a portion of the set based on the range and other options. So I can do Z-range 0 to 9, or I can do Z-range -1 to -9, or -10, and that will give me, in order, what I want. The volumes are unique for sets, but can the score be duplicated? Say player 2 and player 3 score the same. It's a good question. Yes. So who will actually be in order depends on who is inserted first. So the first person to have a score of 20 will be the first person that occurs in there. Now, with sorted sets, you can write your own code to kind of dictate who actually comes in first if you want to change that, if they have the exact same score. But that's more looking into like the actual code of Redis, which isn't a problem. Or you could write a little bit of a wrapper around sorted sets. But yeah, these are really good questions. And you're thinking of edge cases, which is really important because users are going to hit edge cases guaranteed. So here we are. We're creating a sorted set of developer advocates at Redis. So the command is zadd. Z stands for sorted set. Add just means I want to add an element and its score to a sorted set. And we give it the key of our sorted set, the value of the sorted set, and the score. So in this case, the key, we could be anything we want. I'll just say developer advocates. And the value will be Guy, Brian, Justin, Steve, Simon, Suze. And the score will be 12,010, 23,740, 56,750, and so on. So you can see that they're all in order, and that just happens automatically within the sorted set. So lastly, we have this concept of caching. And caching is the main thing that people use with Redis, which is perfectly fine. My job is to tell you how you can use Redis in different scenarios. I'm not trying to sell it. I'm just trying to share it with you. But caching is the #1 thing that we can do, and that's perfectly fine. So if you haven't played with caching before, cache is a hardware or software component that stores data so that future requests for that data can be served faster. The data stored in a cache might be the result of an earlier computation or a copy of data stored elsewhere. Now, when I was a long time ago, I was teaching at a developer boot camp at General Assembly. And my favorite example of a cache was coffee. In our campuses, we had a big pot of coffee that was always full, and we have mugs. So instead of me going all the way to the coffee pot in the break room and drinking coffee from a paper cup and then throwing it away and then going back to the classroom, I filled a mug full of coffee. That coffee was closer to me in my mug, and that made it so I didn't have to walk to the coffee pot every time I wanted a sip of coffee. It's a really kind of oversimplified example, but it keeps a value close to you, as close as possible or as fast as possible to access it, so you don't have to go to the original source. Does it consider multi-level cache? Multi-level cache would be something that's a little bit more complex that you would actually have to implement. So we are simply the platform. If you want to create a more sophisticated caching system, then you would implement that. We actually give you that freedom. So that's a good question. So here's a very basic overview of a cache, an example of a third-party API response. So you have your application code, and say you wanted to look up, weather values near a certain user, or if you want to, create like a mix match, service where like, oh, this is your location. Here are the top 5, Yelp restaurants. What you usually do is you make a request to your third-party API. That comes back to you, and you serve it back to the user. That's perfectly fine. The problem is that that's a little slow. It can be a little slow. And because you're going to their servers, you're not quite sure where their servers are located. And you might actually be rate limited for how many you can actually request. So you might get like 1,000 requests per hour or per minute, whatever plan you are on. So it actually behooves you to kind of keep that data like bookmarked or remembered locally for yourself. Yelp reviews, for the most part, don't change, by every hour. So you can actually hold on to those like top 5 Italian restaurants in San Francisco. You can hold on to that for maybe, I don't know, 2 weeks, 3 weeks. It's kind of volatile down there as far as tastes go. So you can actually figure out how long you want to keep that data. But what Redis does is it just exists between your application code and the API. So what will happen is your app will look into Redis and see if it has data stored already about what it's wanting, say the weather or the Yelp reviews, if someone's currently logged in, things like that. Now, if Redis does have that value, that's called a cache hit, and that's awesome. That means you don't have to go all the way to the server for the API, and you won't incur, a usage or a fee or anything like that. And it'll go back to your application code, and that's it. Now, the speed ups, if you tune it properly, we've seen it go from 1 second to 0.5 seconds down to like 25 milliseconds, which is very, very considerable, very fast when you're thinking about using an application. Okay, so that was a happy path, a cache hit. Now I kind of want to show you a cache miss. This is not the happy path. Still not bad, but it's not the best. So your app's going to look at Redis. Hey, Redis, do you have this value that I'm looking for? Now, what if Redis doesn't have it? That's not really a problem. It just means that you're going to have to go to your original source of cache, which is going to be the third-party API. Then the API will give you the data as normal, and then they'll go straight to the customer, the user, which is what you want. And then afterwards, you'll add that value that Redis didn't have into Redis. That way, in the future, Redis will be able to serve that up. And that's a very common pattern. There's a couple different patterns as far as caching and keeping your caching up to date. This is, I'd say, one of the more basic ones. But you could implement this with some basic logic in any of your applications. Okay, excuse me. Now, you can do that with a third-party API, or you can do that with your SQL database. It's perfectly fine. What you can do is actually associate different SQL queries with some kind of key command that you set for Redis, and it can actually look up that data if it's commonly used SQL commands. So if you're looking up, the top 10 restaurants in Philadelphia, or top 10 pizza restaurants in Philadelphia, probably a lot of people ask that same question. I did last night as soon as I flew in. So what you can do is you can check Redis. And again, if Redis knows, I got you. I'll tell you. If it doesn't know, then it will go back to your SQL database. And the SQL database, with that command, will pass it back to you. But then since you have the logic in your code that says, hey, we didn't have this in Redis, we should put it in there, you can put that SQL command into Redis. You can literally save it as a string. Now, you will have to actually kind of monitor like, hey, maybe if there's like over 100 people a day that are asking for the same query, or maybe 50 or 25 per day asking for the same query, maybe it's worth it to add it to my Redis. But that's up to you. Again, we don't create the software or the infrastructure around Redis other than the client library and some of the like search functionality libraries that we have above it. Up to you, which is often, I think, much more freeing than actually having to use our, any kind of proprietary software. Okay, so caching is actually really easy when caching is very easy when dealing directly with Redis. So you only just ask it if it has the value. So again, we're going to use get. So if we're going to use strings in our cache, we can just use get. If we're using JSON in our cache, which is great if you want to actually have a little bit more complex objects than just like a simple string, it's pretty much the same command, only it's called JSON.get. So there's no big difference. And again, if it exists, great. If it doesn't exist, fetch it from the original source, then return it. And then when you have time, return that data that you fetch from your third-party source, send it into Redis. And we're going to use the command setX. Now, set is just simply create this key and just have it last there. SetX is create this key, create this value, but I want it to exist for only a certain amount of time. That's known as a TTL, or a time to live. Now that means I want this value to exist in my cache or in my Redis for X amount of seconds. Now, why would you want to do that? Data is precious, data is king, data is money, right? Well, yes, but stale data, invalid data, incorrect data, that's garbage. Nobody wants incorrect data. So an example of this would be if I'm looking up the weather. Fall and spring are excellent examples. So, well, Philadelphia is beautiful and sunny, but where I live in Washington, I left yesterday morning and it was pouring down rain and it was like 45 degrees. 2 hours later, it was sunny and it was 55 degrees. I was very upset. But if I cached the weather data, if I cached it and it was 45 degrees and raining, if you set that as the value of the weather in my area code, or my zip code or whatever, that data would be out of date. So you want to keep it existing for only so long. Otherwise, you'll be serving wrong data. Somebody will be looking out the window and seeing sunny skies and birds tweeting, and your app says it's still 45 and pouring down rain. So you want data in your cache, but you want data in your cache to be lively and relevant. So that's why we always recommend you set an expiration. Also, this prevents you from filling your Redis server with data if you hit like a memory limit or something like that. Then you have problems of, well, how am I going to evict keys? How much space am I, allotting for my cache? Things like that. Okay, so I have a couple caching examples I'd invite you to look at. This whole slide set is actually in the repo that I listed in the beginning, so you'll also see these in there. Let's see here, we have a question. With a cache hit, would you ever then try to check the database to compare the last modified date of each record? To check if the date is outdated in the cache but not request all the data? Or should tune this expiration? Let me think on that real quick while I drink some water. Well, you wouldn't actually write to the data. This is a good question. You wouldn't actually write to the database if the cache hit is successful. So more often than not, the data isn't out of sync. But if you can find a use case where the database might have a value that is newer than your cache, then you'd want to fine tune it. And you want to actually have, I'd say, to imagine a service that would either update the cache from the database, so that have your own microservice, not from your main application, but it's a service that basically mines the cache and your database to actually monitor that. To check if the data is outdated in the cache, but not request all the data. So you can update it. So a partial update to your cache. That's good. That's very smart and that's very small. So that'd be very incremental and that would be inexpensive. that would be definitely something that you'd want to fine tune, because Redis, again, is simply the platform. We're just commands. It just turns out that you can do a lot of fun tricks with this. Okay, so JSON capabilities. So Redis stacks, now I'm talking about Redis stack, which is the kind of the wrapper built around open source Redis. Redis stack stores and retrieves JSON as a native data type. So within the JSON, you can store everything that you're used to. So lists, strings, numbers, booleans, and sub-objects. This reduces the need to convert your JSON to and from strings. And this is actually really important because when you're dealing with larger JSON, if you're not sending just very specific small payloads, that is actually pretty costly on your front end and your back end. Also, while you're deserializing, if somebody's requesting that data, it might be out of date. With the JSON commands for Redis, you can retrieve all of their JSON or just specific components, subcomponents of your JSON. That reduces the payload. And then it's all things we know: set, get. You can append to an array in JSON that exists in there. You can also toggle Boolean values. It's very nice. Sorry, the air conditioning in here is pretty horrible. Lastly, Redis stack facilitates search of hashes in JSON. So within JSON, you can actually tell the search capability to look at all keys that are JSON of a certain pattern. So if I'm searching books, I want all my JSON objects that have keys of books : to be indexed. Now, when you say something is indexed, that means that there's going to be a data structure that actually watches all the values of the text or string values within a JSON or geospatial coordinates. And it watches that and it'll reference that for you if you search it. All previous, now with Redis, if you've been adding JSON books with a key books, and then you index, it's going to look at all of your previous keys and all of your future keys. So you don't have to like roll back or redo anything. Now, this is really good for creating autocomplete and then just searching. And you can create very instantaneous features like filtering, tag search, stuff like that. Now you see here, when I say search full text strings and tags, tags would be like in a blog post, if it's like something like IoT or vacation. Single words that are not unique, that would exist among different topics. So another excellent example is within social media, hashtags, stuff like that. Search in JSON is a little bit more involved. Not too bad, but search is a little bit more involved than just simply showing a simple code example on the screen. So we do have a couple different examples that you can actually try. One is a discography CRUD app, and then another is a Python address book CRUD app. And we have plenty of different examples on our repos of different utilizations of JSON with search. Yeah, and of course, you can also contact us, and we can, definitely work with you to show you more complex examples. All right, so if you would like to learn more, and if you have more time, we have our own little tiny university where we have videos, code samples, very extensive tomb of knowledge. And this is for if you want to learn Redis for your specific language, you want to learn just the basic data structures, you want to learn how to scale up Redis with clustering like Pokemon Go did, or if you want to learn about setting up JSON and querying, we can help you with that. If you don't want to take a whole course, if you just want to watch us talk, we have a pretty big YouTube channel. You can see me in there. I talk a lot. I don't lose my voice, I promise. And we'll go through a lot of different data types and kind of use case scenarios. So I can actually show you, I have a video in there where I actually set up a cluster. Where I set up a cluster or I set up caching. We also have a Discord that you can join. So discord.gg/Redis. There's tons of questions and answers that go on in there all day. So no question too small or too big. We're always happy to help. And yeah, that's pretty much it for kind of what I wanted to share with you. And I would definitely love to open it up to any questions that you further have. I will try my hardest to answer them. And try to find a little bit more water. Yes, we have certifications. So each course you take does have an exam. If you decide to take that exam, you'll get a certificate of completion. Also, there is a Redis developer certification. Now, that one is going to be a tough one. I'll tell you completely honestly. I would recommend, we have prerequisites. You take about 3 or 4 different courses. And then once you get comfortable with Redis, you take that. It's a timed 2-hour, 80-question exam. And if you pass, then you get a badge that you can have a certificate of completion on your LinkedIn. And that is really good to have. It used to be $100, but I got kind of pissed off at that. It's like, why are we gatekeeping knowledge with money? So it's free now. So please take it and please consider it. Since we have a little bit of time, yeah, no, thank you. I have my little backup Monster Energy here. Since we have a little bit more time, I could actually show you one thing that I love using with Redis is our Redis Insight. Let me see. Mary, can you add my my new screen to the streamer? Thank you so much. Okay, that looks pretty good. Cool. So this is Redis Insight, and this is what happens inside Redis. So I'm going to use the command ping. Ping just says, hey, are you alive? And it goes pong. I'm looking at down here, pong. So let me show you like just some simple examples. Set foo bar. Okay. Get foo bar. There you go. So I can do, let's see here, L push, and I'll create a list of 1, 2, 3, 4, 5. I'll call L range 1, 0 to -1. 2, 3, 4, 5. I actually, L push, here, I'll show you my list. And then 1, 2, 3, 4, 5. And so I created a list, and then L range, my list, 0 through 2. It'll give me 5, 4, 3. So I'm pushing things from the left to the right. So that's why 5, 4, 3 are all the way at the end. This is really good because this shows you all the keys that you have. So here's my list. Here's the list structure, and it shows you it's a list. Here's my foo string. Set it as foo. And then I can set, let's create JSON dot set my JSON $, which is the root. And then here, writing code off the cuff, nothing could ever go bad. Okay, so I created a very simple JSON object of foo and bar. So if I reset up here, there we go. Here's my JSON, and I can see it's foo and bar. This is really great for experimenting. So Baz is my property, and my value will be, say, can I do this? 1, 2, 3, 4. There we go. I think that's going to be a string. I can maybe change that to an array. There we go. So now I have an array stored in here. And so this is just a really great way of interacting with your data. You can also kind of learn as you play with your data. We have a couple different tutorials throughout here. And then once you start getting your data set up in a way that's kind of crucial to your application, you can start doing database analyses. And that will actually run, so you can see what key distribution you have, what is in your memory. Also, while you're running your code, you can show your profiler. And this will show you like what commands are being run on your Redis server. So as people are using your application, you can see all the commands, and then you can start seeing if you should change your database structure in a way that makes those commands required less, or if you can just spool up another Redis server to only serve those hot commands. So there's a lot of different options you can run with this. So, are the certifications done online or at a location? They are all online. Yeah. So we are the developer advocates. We're actually spread across the United States and EMEA. So everything's done online, and you can actually do it at your convenience. There's no time for anything like that. We also had proctors during the pandemic, but nobody likes a proctor. It was quite invasive, and I read some very horrible articles about what was going on. So we just trust you. You know, it's a trust system. Um, so yeah, anytime you want, you can do it at midnight. You can do it at 2 a.m. How much data should you store in the value? Is there any guidelines on how much stuff you can jam in there? That's the really dangerous question because you don't have a whole lot of limit. We do have a limit on the size of key. You can actually name your key up to 512 megabytes if you want it. I think the value, don't quote me on this. I think it might be 37,000 megs or gigs. um, the what we actually recommend is that you store what you want and then you observe how it acts. So you can actually encode like images and video into like base images at least into base 64. And you can store it in the Redis. It gets pretty big. So what we recommend is you kind of, if you have like a huge JSON that is like over, say, maybe 20 megs, kind of break it down into modular pieces that are logical. So pieces that are often requested, pieces that aren't often requested. Also, if you're storing a large value such as JSON, more often than not, you're only going to be, picking out individual bits and pieces and certain properties, which we allow you to do. Within the JSON request command structure, you can just call certain sub objects or certain ranges within an array of objects, anything like that. So the fun thing about Redis is that you can store a lot of large objects, and they don't all have to be large. You don't have to have any schema if you're not searching among them. So again, just experiment, see what happens, and if it breaks, just back off and then try again. And if there are like really interesting use cases that you kind of want to get clarity on, we can always chat and kind of suggest some alternatives or some solutions that would work to your specific use cases. Because again, I'm an advocate. Pay for like the Redis cloud or not, I'm here for you and I'm going to help you because I just want people to like Redis. So it pays my bills. So. And so Skull Crusher for life, great name. Also, you can just pull a portion of the value out if you know the key. I always thought it would pull the entire value out. Yeah, if you know the key, what you want within that JSON object, you can go straight down, you can drill down. And we use the JSON path syntax, which is a little bit of like an enhanced dot notation. And I have that covered in some JSON videos. So with Redis Explained, when you look at JSON Explained Part 2, I actually talk about the JSON path syntax. It's relatively new, I'd say about 3 or 4 years, but it's very powerful. You can get ranges, you can do recursive drill downs into JSON. If you remember XPath, it's kind of like XPath, which might make some people cringe, but it's really great. Codemtardv, sorry, mangled your name. For the final exam, are there some extra preparations required than the course itself? We have a couple prerequisite courses, streams, and intro to data structures and algos. Those are 2 very important and rather sizable courses. So between those 2, you're going to have a good overview of what Redis does. And then we request that you take another elective just to really round out your education. There is a basic exam prep that we have that will kind of show you what we're thinking you should know for this exam. Also, this is a hard exam, and it's you have only 2 hours, which is maybe enough, maybe not. We allow retakes. It is literally me pulling the lever on the grading and interacting with you. So, I'm not going to be, you took the test once, you could never do it again. No, that's totally fine. I recommend you take 2 weeks just to kind of review the material. We'll give you a breakdown of like what areas you'll need to work on, things like that. But the gross majority of people that take the exam have already done a lot of work to go into this exam by taking the courses. So the gross majority of people that do the exam pass. And that's from me actually watching every week people pass. So hopefully that answers your question. To keep the lights on, I should tell you that a lot of people, if they're not running Redis locally, or if you're not like, spinning up your own server instance and running it on your own server, you have options. So Redis does offer cloud hosting for a quite affordable amount. Also, for MLH participants, you will also receive a discount code, which will give you enough money to have you play with a decent sized Redis cloud instance for at least a month or two, depending on how big you thrash your database. That's really nice because then you can actually have built-in replication and data backups. Also, you don't have to have the server running on your computer, so you can have multiple people developing on your Redis server at the same time. And with Redis servers, you don't have to like have any kind of multiple databases if you don't want. We actually are against multiple databases of the same instance. You just run up another Redis database. I personally like using just one Redis database that holds all of my values because it's so big and my key naming convention keeps it organized. Yeah. Also, if you want to set security features, things like that, Redis has built-in ACL access control lists. Redis Cloud has a great user interface, so you can like grant certain applications only the ability to read or only the ability to write, or you can give certain developers only the ability to read or write certain commands, or even just like have access to keys with a certain pattern. So does the cloud service host any other databases so you can fiddle with cache hits and misses? It doesn't host any other databases other than Redis. But you can always have, I would imagine, like a SQL cloud instance running. Most of the database services that are out there have the cloud connected. So that is actually a very interesting endeavor of actually having multiple cloud instances, like caching for one another. That's a good question. That's a very good question. And those hits and misses, you can record those by writing your own code base. Because again, the platform for Redis is very, very focused on just input and output of data. We do have some metrics that we can actually show you within redis.com. When you create an account, you can see metrics through there. Otherwise, there's a lot of good services that will monitor your Redis for you locally or in some other cloud service other than Redis. Off the top of the mind, Grafana is really great. There's a Redis plugin that will show you more than you would ever think you wanted to know about a Redis instance that you own. So yeah, Grafana is really good for that. Cool. So I just want to remind everybody one more time that can you run Redis in a container? Yes. Redis is perfect for running in a Docker container, and it's very Kubernetes friendly with running multiple instances. Developer advocates, we all run our Redis instances in Docker containers because we're using different versions just to kind of test out our cutting edge versions and test legacy for future changes. But I actually recommend instead of downloading and compiling Redis on your computer, or even using if you're using Mac, instead of using Homebrew, just use a Docker container. If you're using Linux or Windows, definitely use a Docker container. You can run Redis on Windows, but you'll have to use PowerShell, so you just might as well use a Docker container. Thank you, ThinkFirst. Yeah, and you want to check out Redis Stack Latest. That's going to give you all the capabilities, and that's the one that I'm using right now. So that's That's the best alternative. And a lot of this data that I'm kind of like spitting out at you, freeform, is also going to be included in all the repositories that are linked within this document, I mean, within this repository and these slides. I also have some videos. If you just look up Redis explained on YouTube, a lot of these questions will also be represented in some longer form videos too.